Alright, this is just going to be a walkthrough of example 3 from page 104 in your workbook. So we're given this function h of x, and the first thing we're going to do to be able to sketch the graph and complete this problem is find the domain. So to find the domain, we're going to set our denominator equal to 0 because we know that's our restriction. We can't divide by 0. So x squared plus 2x cannot equal 0. We factor that, we get x times x plus 2 cannot equal 0, and that gives us that x cannot equal 0, and x cannot equal negative 2. So our domain is negative infinity to negative 2, union with negative 2 to 0, union with 0 to infinity. So we're not including negative 2 or 0. And next, for our intercepts, for the y-intercept, that would be finding what h of 0 is. So when we plug in 0 for x, but we can't have h of 0 because 0 is not included in our domain. So since x equals 0 isn't in our domain, there's no y-intercept. For the x-intercept, that's setting h of x equal to 0. And when we do that, we're going to solve for when the numerator is 0, because 0 over like a number that's not 0, so like 0 over 8 is going to be 0. So 2x squared minus 8 equals 0. Factor that and we get 2 times x squared minus 4 equals 0, which becomes 2 times x minus 2 times x plus 2 equals 0. We get x equals 2 and x equals negative 2, but negative 2 isn't in our domain, so we only use x equals 2. And so we have an x-intercept at 2, 0, and no y-intercept. Now for the end behavior, so we have to find what is happening at the ends of our domain. So in this case, it's negative infinity and infinity. And so for this, we have to find the limit as x approaches infinity and as x approaches negative infinity. And so here what we're going to want to do is multiply by 1 over x to the b over 1 over x to the b, where b is the highest power on an x in the denominator. In that case, this is 2. So we're going to multiply by 1 over x squared over 1 over x squared. And when we do this for both problems, we're going to be doing that. And so we're going to have limit as x approaches infinity of 2 minus 8 over x squared over 1 plus 2 over x. And the same thing for the negative infinity. And in both cases, the 8 over x squared and the 2 over x are going to end up going to 0. Because 8 over infinity is going to be 0 and 2 over infinity is going to be 0. And so we're going to have 2 minus 0 over 1 plus 0 equals 2. So both of these tell us that we are having a horizontal asymptote at y equal 2, or you can think about it as x approaches infinity, our y values approach y equals 2, and as x approaches negative infinity, our y values approach y equal 2. And the reason we use this 1 over x to the b over 1 over x to the b is because then we can easily evaluate this limit. We know limit as x approaches infinity of 8 over x squared. Whenever you have a number 2 over infinity squared, that's going to go to 0. So then those just easily become 0. And yeah, then it's easy to evaluate. So that's why we use that method. Then we have to find the behavior in between intervals. So that's going to be what is happening at negative 2, or as we approach negative 2, and what's happening as we approach 0. So first, what I would always do, I'm going to start with negative 2, and I'm just going to plug it in, solve the limit by plugging in negative 2 and just see what I get. And I see that I get 0 over 0. So this tells us that we have a hole at this x value when we have 0 over 0. So we need to solve for the y value of the hole. So then what I'm going to do is basically I'm going to do this where I can cross out the hole to see what y value would there be if I didn't have a hole there. So we factor it. 2x minus 2 over x plus 2 over x plus 2. If we cross out that whole and we plug in negative 2, we're going to get negative 4, which tells us that our y value at the whole at x equals negative 2 is y equal negative 4. Because that's what we get when we like cross out that whole, so that's what our y value would be there. But this x plus 2 over x plus 2, having to cross that out tells us that there was a hole there. And then as we approach 0, we get, when I just plug in 0 to see what I get, like not from right or left, I just plug it in and see, I get negative 8 over 0, which is a number that isn't 0 over 0. And so instead of 0 over 0 telling us that we have a hole, a number that isn't 0 over 0 tells us that we have a vertical asymptote. So we have to find the right and left limit and see if it's going to infinity or negative infinity. So as we approach 0 from the right, I'm going to try plugging in 1, because it's just 1 above. And I get a negative over a positive, which is a negative sign. And this means as we approach 0 from the right, our y values go towards negative infinity. And so yeah, that's what this looks like. And then so this is just to show, in case you're ever confused, negative 6 over 3, that's like negative 2, so why is this going to negative infinity? It's just because 1 is just like an easier number to pick. We're just looking for the sign. But if you were like, I really want to see that this is going to negative infinity, you could plug in a number even closer to 0 from the right, like I did 0.01. And as you can see clearly, as we get closer and closer to 0, we're going to negative infinity. But you can really just do like 1 above the number, 1 below, because we just need the sign. And then from the left, I tried negative 1, and I got a negative over a negative, which ends up being a positive, which means as we approach 0 from the left, our y value go towards positive infinity. Okay, and then bringing this all together, when we graphed it, first I graphed my x-intercept at 2, 0, and my hole at negative 2, 4. And then I just kind of followed the limits and what I wrote. So as my x was approaching negative infinity, our y values are approaching y equal 2. And then as I approach 0 from the left, my y values go towards infinity. And then as I approach 0 from the right, my y values are going towards negative infinity. And as my x approaches infinity, my y values approach y equal 2.